Would you like to help your students brush up on their graphing? Try a little toothpaste. Hello, I'm Rico Tyler with the National STEM Scholars Program, bringing you another video to help you bring more phenomena-based science, more claim evidence reasoning, and more sense-making into your classroom. Today, instead of looking at a specific performance expectation, we're going to look at the science and engineering practices dimension of the next generation science standards. In particular, analyzing and interpreting data and arguing from evidence. One of the most common ways that people analyze data, interpret data, and make arguments based on data is to graph data. Graphing is that classic skill that everyone needs to know. The problem is, how exactly do you teach that? To teach that, you got to have students making graphs and using graphs. And not just using them in the sense of, I complete a graph, I turn the graph in. The graph needs to be a tool that a student makes and interprets data, makes a prediction. Actually, in the bigger world beyond the classroom, in the commercial world, using graphs to make predictions is very common. An air crew, for example, will graph their fuel consumption so that they can predict how long their airplane can stay in the air with the fuel that they have. A manager at a factory will actually keep a graphical chart showing how much of different supplies, raw materials and parts are in the factory and use that to predict how long their supplies will last. What we're going to do today is show you how you can do something very similar on a small scale within your classroom. The activity I'm going to show you today is not intended to be done in a single day. It's intended to be an activity that would take a little bit of class time over a whole range of class periods. The goal of the activity is very simple. Here's a tube of toothpaste. Can we predict, before we actually use the entire tube, when you're going to run out of toothpaste when you start with a full roll like I have right here? The way you do it is simple. Start by getting a balance. I have a balance right here. And figure out how heavy a full tube of toothpaste is. And in this case, it's 168.9 grams. Now, different brands of toothpaste can be large and small tubes. Most toothpaste, all of it I can tell, is loaded by a machine. And so you'll discover that the actual gross mass of a tube of toothpaste is extremely consistent. I've measured half a dozen of these tubes and they are all within a gram or so of each other. The next thing that you need to do is to find out how heavy a tube of toothpaste is when it is completely empty. Which means that before you start this experiment, you need to keep the last tube, make sure it's good and empty, and measure the mass of it. For a tube of toothpaste like this, that comes out to be just about 12 grams. The next thing that you're going to do is simply bring the tube of toothpaste to class about every week or two. There's no general rule about this. Doing it every 2 weeks is perfectly fine. To bring the toothpaste in, measure the mass of the toothpaste, and then your students will create a graph that's going to plot the mass of the tube of toothpaste versus the number of days since the toothpaste tube was new. You can do this as individual student work where every student is maintaining this graph. You could even do it as, say, some large graph that's maintained as part of a bulletin board. But the key here is that every 2 weeks, students, or 10 days or 5 days, you don't have to do it on a regular basis like clockwork, but whenever you bring in the tube, you find the mass of the tube, and then students will take the data, extend the graph that they're making, and then extrapolate to try to make a prediction of when the tube will finally go empty. And each time you bring the toothpaste tube in, they will revise that prediction to see at the end of the time, when you finally use up the entire toothpaste, how far in advance of that date could they or did they actually predict the last day for the toothpaste tube. What I'd like to do now is to show you what this looks like in an actual experiment. Here you see a graph showing my tube of toothpaste with 2 data points. You can see the first data point is that 169 gram full tube of toothpaste. And then 11 days later, I measured the tube of toothpaste again, and you can see the second data point shows that it had gotten down to 150.7 grams. Now, if you take those 2 data points and extrapolate, you get a graph that looks like this. Somewhere between 95 and 100 days after the tube is new, I'm going to run out of toothpaste, at least according to these 2 data points. But of course, that assumes that I'm going to use the entire tube. The tube itself, the empty tube, has got to be accounted for. So if you account for that, 12 grams, then it looks like sometime around day 91 or day 92, I'm going to run out of toothpaste, at least based on 2 data points. So that would be the initial prediction. Well, let's go a little further. I collected some data on day 31 and on day 44. Now I have 4 data points. And you can tell these data points are pretty much lining up in a very straight line. I've discovered that people tend to be very consistent in their use of toothpaste. Now, if we extend that graph, now you see that it looks like with this new data, 80 or 81 days seems to be about when that's going to happen. Here are 2 more data points at 72 and 84 days. And as you can see, it's going to be closer to that 90 value. Now it looks like I'm going to be done in about 85, 86 days before I'm finally out of toothpaste. Here I have one last data point in my nearly empty tube of toothpaste. And my last prediction is saying somewhere around 86 days. If you notice at the very beginning of the experiment, we were thinking more like 90. The graph eventually looked more like 80. And in the end, it looks like we're going to be close to 85, 86 days. When I actually did this experiment and went to the very last day, it was 87 days, almost exactly 90. As you can see from this example, consumption of toothpaste is extremely consistent, and students can get a very accurate estimation of when that tube of toothpaste is going to be empty weeks or months before you actually get there. Now, I did this experiment with toothpaste, and I think toothpaste is a very good way of doing it. But there are lots of substances that are around the house, some in the kitchen, some in the bathroom, that are used at very consistent rates and could be used as the basis for running this experiment and giving students a chance to take real data and make a real prediction from the graph and then see how close their prediction is to reality. This is exactly the kind of using data, analyzing data, arguing from data that we want students to get practice with. As always, thank you for watching. I think you will find this an extremely good way of bringing graphing into your classroom. Until the next time, goodbye.